Hello, today we will talk about superposition principle. Superposition principle is a very general theorem in physics. It applies to situations where cause and effect are related by linear relationship. Let us assume that we have a system in which a cause CA produces an effect EA and another cause CB produces an effect EB. When both causes Ca and Cb are acting at the same time, according to superposition principle, the total effect will be Ea plus Eb. That is, if causes add, effects also add in linear systems. We can now look at an example. We have a mass m, the cause is a force F1 and the effect is acceleration A1. So we can say that cause F1 produces effect A1, which we can find out from Newton's law. Now if we apply a different force F2, the effect A2 will also be different. So F1 cause produces A1, F2 cause produces A2. If both F1 and F2 act on the mass simultaneously, the resulting acceleration A is equal to F1 plus F2 by m, which we can express as A1 plus A2. That is, when causes have added, the effects have also added. Now we want to see how superposition principle applies to an electric circuit. What is a cause in an electric circuit and what is an effect? The effect is simple. The voltage across or the current through a circuit element is the effect or the response in an electric circuit. The question is, what causes the current through a circuit element or voltage across a circuit element? Let us look at two situations. In the first case, we have an independent voltage source connected across a resistance R0, and the current flowing through the resistance is I0. We can say that this I0 is produced by the independent voltage source Vs. So in this case, I0 is the effect and the independent voltage source Vs is the cause. In this example, the independent current source Is is flowing through R0 and the voltage across R0 is V0. Here the effect is V0. We can say that here the effect V0 is produced by the independent current source Is. So in this case, Is is the cause. If we generalize these observations, we can say independent voltage and current sources are the causes or the excitations in electric circuit. Okay? So how do we define superposition principle for electric circuits? The statement goes like this. The voltage across or the current through an electric circuit element is the algebraic sum of voltages across or the currents through that element due to each independent source acting alone. We need to understand what this statement actually means. Let us look at this circuit. We have a resistive network here and I have highlighted the resistance R0 whose current I0 is my desired effect. There are two independent sources in this circuit. Vs, the independent voltage source, and Is, the independent current source. This I0 contains contribution from both causes Vs and Is. Using superposition principle, we can find out what is the contribution of Vs to I0 and what is the contribution of Is to I0. If these two contributions can be separately determined, I0 will be the sum of these two contributions. Okay? So, to find out the contribution from Vs, we need to deactivate Is. Again, to find out the contribution from Is, we need to deactivate Vs. We now see how to deactivate a voltage source or a current source. In this circuit, if we apply Ohm's law, I naught can be written as Vs by R naught. To make I naught equal to 0, we have to make Vs equal to 0. So if in this circuit Vs is made 0, there is no contribution of Vs to I naught, and we can say that the independent voltage source has been deactivated. Now 0 voltage is equivalent to a short circuit. So we can say that to deactivate an independent voltage source, we replace the voltage source by a short circuit. In this circuit, the response or the effect V naught is equal to Is R naught. This comes from Ohm's law. V naught is 0 when Is is 0. That means by making the value of the independent current source equal to 0, we can deactivate an independent current source. Zero current is equivalent to an open circuit. That means that to deactivate an independent current source, we replace it by an open circuit. Okay, let's go back to this circuit. We want to find out the contribution of the independent current source Is and the independent voltage source Vs separately. To find the contribution of the current source Is, we make Vs equal to 0. That is, we short circuit the voltage source and Vs is deactivated. Then the current flowing through R naught, we call it I naught 1. This I naught 1 is the contribution of the independent current source Is to our response I naught. This I naught 1 is due to Is only. Next, to find out the contribution of the voltage source Vs, we make Is equal to 0. Then Is is equivalent to saying that it is replaced by an open circuit and it is deactivated. Now the current that is flowing through R naught, we call it I naught 2, and this I naught 2 is due to voltage source only. That is, I naught is due to Vs only. If we look at our original circuit where both the Vs and Is were active simultaneously and the response was I naught, this I naught can be found from our knowledge of I naught 1 and I naught 2. Superposition principle says that I naught is simply equal to I naught 1 plus I naught 2. Okay. In this context, we need to remember a very important point. A dependent voltage source or a dependent current source is not a cause or an excitation, because a dependent source cannot supply any voltage or current unless it is activated by another circuit variable. Only independent sources are causes or excitations. We deactivate only cause or excitation in an electrical circuit. So we only deactivate independent sources. We never deactivate a dependent source in a circuit. We can now summarize the steps that we will follow when applying superposition principle to a circuit. First, we consider applying superposition principle to only those circuits which have multiple independent sources. In step 1, we will consider only one independent source active and deactivate all other sources. Then we will determine the desired response, which can be a voltage or a current for this independent source acting alone. We will repeat these two steps for each independent source in the circuit by turn. Once all the independent sources' contributions acting alone have been calculated, the total response is equal to the algebraic sum of all the contributions from each independent source. And in this process, we remembered not to deactivate any dependent source in the circuit. The dependent sources always remain active when we perform steps 1, 2, and 3. We now look at an example. We want to calculate the voltage V0 across 2 ohms resistance using superposition principle. We have two independent sources, the 8 ampere current source and the 20 volt voltage source. Let us consider the contribution from the 8 ampere source first. We will have to deactivate the 20 volt voltage source by a short circuit. Then 20 volt source is replaced by a short circuit and we call the voltage across 2 ohms V01. V01 is the contribution of the 8 ampere current source only. Now let us say that the current flowing through 3 ohms and 2 ohms series combination is I1. These two in series gives us 5 ohms. This 5 ohms and this 5 ohms are in parallel. We can use the current divider rule and calculate that I1 is 4 ampere. The two resistances are equal, so the current will also divide equally. Then we apply Ohm's law to the 2 ohms and find out that V01 is equal to 8 volts. Next we consider the 20 volt source only. For that we will have to replace the 8 ampere current source by an open circuit. This is the circuit we get. Now the voltage across 2 ohms is called V02. V02 is due to 20 volts independent source only. All these resistances are in series and we are interested in the voltage across 2 ohms. This 5 ohms and 3 ohms can be combined in series to give a resistance of 8 ohms. We can use the voltage divider rule and calculate V02 is equal to 4 ohms. I mean 4 volts. So in this circuit, our original circuit, the contribution of the 8 ampere current source to V0 is 8 volts. The contribution of the 20 volts voltage source is 4 volts. When we want to find out the total contribution, we add these two contributions and V0 is equal to 12 volt. Here is the application of the superposition principle. That's all for now. Thank you.